Hey everyone, welcome back. In this video, we're going to be going over section A, problem 5. If you don't yet have yourself this PDF, you can grab it from the link in the description. So let's get straight into it. Part A, build this part in SolidWorks. Use the values below as needed, then find the mass of the part in pounds. Okay, so first things first, we know that we need to switch our unit system to pounds, since I don't normally use it. Okay, everything seems cool. Hint, this part can be built using only one features. Okay. Let's check out the model. So we have a circle on both sides and a straight section in the middle. Okay, so let's jump into SolidWorks and get started. So, getting into SolidWorks, we're going to draw a circle on the one side, a horizontal line in the middle, and then a circle on the other side. The two circles are equal, so let's set those two to equal, and we can offset this bidirectionally to, if we go back to the question, the dimension is 0.4. So that's 0.4 across the entire width of it. So the way the offset works is that it will calculate based on only one side, so from the center line to one edge. So we need to put in 0.2 to get our final dimension of 0.4. Okay, that's looking good. And then our circles, we have a radius of 0.4 and 0.4 on the opposite side as well. So let's get back to SolidWorks and put that dimension in as well. So we have 0.8 diameter on both sides. Then we can trim away some of the pieces of the lines that we don't need. And going back to our PDF, we can add in our dimension between the two circles. So that dimension is given as 3.25, and that gives us our basic shape. So heading back over to our PDF, we have a hexagon on the one side that starts from the center, and a hexagon on the other side that's open, but this hexagon is offset, so it's sort of set towards the far end of the circle. So let's get those hexagons in now. Heading back over to SolidWorks, we'll go over to our hexagon tool. We'll put in the easy one first. We got that one, and we know that this one is set a bit further away from the center, like so. These two are equal. So first things first, let's make this coincident to the center line and set these two to equal and collinear. Ooh, we seem to have an issue. So let's do away with our collinear. And let's make both of these horizontal. Okay. So we'll see if we have any other issues with constraints later on. So going back over to our dimensions, across flats of our hexagon, we have 0.5 on both sides. So let's add that in. Dimension of 0.5, 0.5, and on this side, we have the same. Since we set it to equal earlier, we have the same dimension on both sides, so that's perfect. Okay, now to figure out where exactly our hexagon sits. So what they give us here is the distance between the edge flat. If you notice, there's a little flat on the edges here, or on the end of the circle. And they give us the distance between the center of the circle and that edge, and they give us the distance between the corner or this segment here of the hexagon to the edge as well. So using those, we can get a distance between So firstly we'll add this line in, make that a vertical line, and dimension it from the center. So that is 0.25, and then between this point and the edge we have a distance of 0.4. Okay, so that's looking pretty good. We'll change that back to a solid line, constrain that to the edges, and we have our shape. So we could go ahead now and extrude our shape out. So actually, you know what? Let's extrude our shape as it is. So now we'd have to select a few different segments to make up our shape. Those ones, and heading back over to our PDF, we have a thickness of 0.3. The other option you have when it comes to sketches like that is to trim away whatever you don't need. So when it comes to sheet metal, that would be beneficial, but in this case here, because it's just a normal extrusion, doing it this way is fine. But the better way to do it would be to trim away what you don't need. Okay, so that's our shape complete. Now to add in our material, we have a material of cast alloy steel. So let's head back over to SolidWorks. And we can go to the search bar on top, cast alloy steel. And we apply that and close. And finally, let's check out our mass properties. We need to change our decimal places. We'll take that up to 4, hit OK. So that gives us a mass of 0.1448 pounds. So heading back over to our PDF, 0.1447. So if you went through the very basic mock test on, or one of the mock tests on SolidWorks websites, you'd see in the questions that they allow for a deviation of a percent either way from the answer. So going by that logic, this answer is within range and acceptable. And that completes this question. If you got the same answer as I did, let me know in the comments. If you got something different, let me know as well. And if you enjoyed this video and it benefits you, give me a like and subscribe. And I'll see you in the next video.